In our last lesson, we looked at graphing quadratics, and we only completed the first step of graphing a quadratic, and that was solving for the roots, also known as the zeros. And we can use several methods to do that. We can use the AM method, we can use factoring by grouping, difference of two squares, greatest common factor, among many other things that we've not learned yet. But solving for the roots is really just our first step. So today we're going to be looking at the second and third steps of graphing a quadratic. And there are many other ways to graph a quadratic in addition to the steps that we're learning here, but these are some of the easiest steps for us to use. So let's look at our second step. Assuming that we've already found the roots, we then want to, as our second step, find the y-intercept. So these are the same two equations that we were working with in our last lesson, so we're going to return to those. So the roots of this equation we found using the AM method last time, and we found that the roots were 3, 0, and -1, 0. And we did that by saying, well, what adds to -2, what multiplies to -3, and then using the zero product property. Let me make that look like a 3. All right, so using that, we plot 2 points on the graph, and that's not enough, so we then have to return and find the y-intercept. Now the y-intercept of any equation, any graph, is going to be where the value of x is 0. So where x equals 0. And that makes this very easy for us. In our equation, all we have to do is substitute the value of 0 everywhere we see x. So we're going to have y equals the equation. Then we can say y is equal to 0 squared minus 2 times 0 minus 3. Now, the nice thing about multiplying by 0 is that it all just disappears. It becomes 0. So the only thing that's left is y equals -3. No real calculations to do there. So our coordinate point is going to be 0, -3. And that is our y-intercept. So if we look at our graph, this is the graph that we had started last time. These were our two roots, -1, +3. We now have the coordinate point 0, -3 as our y-intercept. And if we look at the completed graph for comparison, we see that that is a point on that graph. So we've done that step correctly. Now notice we only have 3 points, and if we were to connect them, we'd get like a V shape. So we need to have at least one more point, and that's what we're seeing here. So we'll get to that as our third step. But let's look at another example before we go on to our third step. This equation here, also from last week, y is equal to x squared minus x minus 12. We know from last time, using the AM method also, that the roots were 4, 0, and -3, 0. And we got that by finding what numbers add to -1 and multiply to -12, and then using the zero product property. So we want to find the y-intercept. Very straightforward. Everywhere we see x, we make it a 0. So it's going to be y is equal to 0 squared minus 0 minus 12, which just gives us y equals -12. So our coordinate point here is 0, -12. Now if we look at the graph that we started last time, we see these are the two roots. We have a 4 and a -3. It was halfway between the -2 and the -4, because this is counting by 2's. So it's 2, 4. Now if we go down the y-axis, we can, at -12, put a coordinate point. And that's going to be very useful for us because that gives us our third point. Now we're not finished, but we are almost finished. So let's look at our third step of graphing a quadratic. Third step of graphing a quadratic is when we find the axis of symmetry. Now an axis is a line, and symmetry refers to when something is the same on the left or the right, or up and down. Those would be linear symmetry, or reflective symmetry. Sometimes we have radial symmetry where it's the same all the way in a circle. For this, we're just looking for a line that goes right down the middle of our quadratic. So ideally, if we were to look at this example we just looked at, the axis of symmetry would be right here down the center. And that's going to give us another coordinate point. So let's solve for that algebraically. There's two methods that we could use for this. One is finding the x value between the two roots, which would make it symmetrical on both sides. So if x is equal to, well, something between these two, that would be finding the average of the two x values. So we want to find the average of 3 and -1. So we're going to say that, we're going to say 3 plus -1, and there are 2 points, so we divide it by 2. We're finding the average. So 3 plus -1 is 3 minus 1, which is 2. 2 divided by 2 is 1. So we know that the x value of the axis of symmetry is going to be 1. So if we were to draw, this is our graph here, if we were to draw an axis, we're going to draw a dotted line because it's not really there, but it's helpful for us. We could draw that on the x value of 1, and we go right down the middle of our graph. And if we look at the finished graph, Well, that's right in the center. But we now need to find the y-coordinate at the lowest point. See on this graph here, if we were to draw the axis on the completed graph, we see that the axis actually goes right through the lowest point on this graph. So we need to find the y value of that coordinate. And we can do that by substituting the value of x into our equation. So we got a value of x of 1, so we substitute that in. We can say y is equal to 1 squared minus 2 times 1 minus 3. 1 squared is 1. Negative 2 times 1 is negative 2. So 1 minus 2 is negative 1. Negative 1 minus 3 is negative 4. So it's y equals negative 4. So this coordinate point that we found is 1, negative 4. And we're going to call that our vertex. You've heard that word before many times. Vertex for our quadratic is going to be where the quadratic stops going down and starts going up. So we can actually plot that point on this graph, 1, negative 4. And when we look at the completed graph, we see that 1, negative 4 is exactly the point that we should have gotten. So at this point, we could connect this in a curve. I'm not going to because it probably would come out looking a little funky. But if we look at our completed graph, this is what it's going to look like. You know what? I changed my mind. Let me give it a try. So we're going to connect these. And we're going to connect them using a curve, and then we go to the vertex, and we come back up. And we could continue that, I suppose, but I'm going to leave it at that. All right, not too terrible, actually. So that's going to be our quadratic. And we could say at that point that we've finished graphing our quadratic. With the arrows at the end, we've indicated that it continues. This pre-made graph actually does continue to the edge of the paper, but it's the same idea. Okay? So let's look at the second method of finding the same result, because this method is a little more common, where there's a formula for finding the axis of symmetry, and the formula is this: x equals negative b over 2a. Now, where do we get this b and the a from? That's from our original quadratic equation. So a is our first coefficient, it's 1. B is our second coefficient, it's negative 2. And c is our third, actually constant, and that's just going to be negative 3. So if we substitute in, well, we know negative b would be negative 2, and 2 times 1 is just 2. So negative 2 is positive 2. 2 times 1 is 2. 2 divided by 2 is 1. And that's exactly what we got in the previous method. Now, we have this formula because sometimes we don't have the roots. We only have this formula, and let's say we're starting from the very beginning. This formula is going to be very helpful for us in those situations. Here, it's not so necessary, but in future situations, this is going to be extremely important. So knowing that the x value is 1, we could find y, but we know already that it's negative 4. It would be the same process of substituting the number in. There's no formula for that. So again, we would get this coordinate point, and we could connect our graph with a curve. Let's look at one more example, and then we'll be finished for today. This is the same equation as over here on the left side. Y is equal to x squared minus x minus 12. We know the roots are 4, 0, and negative 3, 0. So we can, as the first method, find the average of those roots, just the x values. So we say that x is equal to 4 plus negative 3, and there are two values, so we divide it by 2. So 4 plus negative 3 is really 4 minus 3, so 4 minus 3 is 1 over 2. So our x value is 1 over 2. Now we could substitute that in to our formula, and we have to find the value of y. So we could say that y is equal to, y is equal to 1 over 2 squared minus 1 over 2 minus 12. Yeah. Okay. So then we can say 1 over 2 squared is 1/4. 1/4 minus half minus 12. Well, now we're trying to find the y value. What would that y value be? So let's make these all of the same denominator of 4. So this would be y is equal to 1/4 minus 2/4 minus 48/4. 1 minus 2 is negative 1, so that's negative 49/4. Ew. So then that's in negative 12. Yep, negative 12 and 1/4. Well, that's gross, but there it is. So now let's use the formula and see if we get the same value of x. So this coordinate point should be, let me write that down first, 1/2, negative 12, and 1/4. And let's use the formula. So the a value is 1, the b value is negative 1, and the c value is negative 12. We substitute those in. Draw a line here. Substitute those in. Negative 1 over 2 times 1. Negative 1 is going to be positive 1. 2 times 1 is 2, so 1 over 2. So that is the same x value, and if we substituted that in, I'm sure we would get the same y value, unless I did that wrong. If I did do it wrong, please tell me. So let's look at our actual graph here. We want to plot the coordinate point +1/2, -12 1/4. So we're going to look for +1/2. Now this is counting by twos. This is going to be 1, 2. So it's actually a quarter of the way across. How complicated. And that's going to be our axis of symmetry. So let's draw our axis of symmetry as a dotted line going down the graph. And notice that when it crosses the actual quadratic shape, it goes right through the vertex point. This point here is what we're aiming for. And it's a little bit below -12, and it's a little bit to the right of the y-axis. So we know that's the point we're looking for. We would plot that point on the line, and then we connect these 4 points with a curve. And notice this curve is a lot more narrow than the previous curve. Quadratics can have all different widths and heights and all sorts of different shapes. So, not the best drawing in the world, but that is our quadratic shape. We have 1, 2, 3, 4 points. We have our U shape, and that is our parabola. So that is how you graph a quadratic, one of the many ways of graphing a quadratic.